Hello friends, today we are going to start our lecture number 4 is the problems on enthalpy of formation. In first 3 lecture we discussed some terms which is used in thermodynamic chemistry. Here we are going to discuss the problem which is based on heat of formation, enthalpy of formation. What is the enthalpy of formation? Enthalpy of formation means when 1 mole of substance is produced, that time how much amount of heat is evolved or formed during this formation. So at standard conditions, when you know there is a standard condition is the pressure is 1 atmospheric and temperature is 298.15 Kelvin is the standard condition, because 298 means there is a room temperature 25 degree Celsius. So if the 1 mole of substance is produced at standard condition, that time the amount of heat which is evolved out or which is present in that reaction is the heat of formation at a standard condition. We call it standard heat of formation. And other than standard conditions, if 1 mole of substance is produced, that time the heat is there, the heat is just heat of formation. Okay. So basically in any reaction, we calculate heat of formation by the subtraction of heat of formation of the, or it is a sum of heat of formations of product minus sum of heat of formation of the reactants. Okay. Using that formula, we are going to calculate the enthalpy of formation. We calculate heat of formation of different reactions, different conditions. Look at here. In first numerical problem, it is given to you, and the problem says the enthalpy of formation of CO2 gas and H2O under standard conditions are 394.65 kilojoules and 285.84 kilojoules per mole. If the standard enthalpy of combustion of acetaldehyde, it is CH3CHO, be 1167.62 kilojoule, then find out the heat of formation, enthalpy of formation of given reaction. Okay, means there is a heat of formation is already provided of CO2 and H2O. Okay, and heat of combustion is given. What is the heat of combustion? Heat of combustion means when at standard condition temperature, pressure, or at just any condition, when 1 mole of substance is burned and to form the products is the heat of combustion. We need the oxygen for any combustion reaction. Okay, so basically here the 3 reactions I already wrote on board. The first reaction is there is a carbon plus oxygen gives CO2. So this is the heat of formation of CO2. Secondly, there is a one H2 molecule and half O2 molecule combined together form water molecule. There is a minus 280.85.84 is the energy. It is a enthalpy. And secondly, it is a combustion. It is the combustion of acetaldehyde. So acetaldehyde when react with 5/2 molecule means 5 oxygens to form twice CO2, 2 CO2 molecules, 2 water molecules. Okay, so here 4 plus 6 oxygens, 2 carbons and 4 hydrogens. Here is the 2 carbons, 4 hydrogens, 1 oxygen and these 5 oxygen, total 6 oxygen. Reaction is balanced. And if this combustion happen, that time the total heat of combustion is minus 11.67. So it is the related to the heat of formation. So heat of formation is directly related to the heat of combustion. Okay, how much heat of combustion? It depends on heat of formation, because when there is a CO2 is formed, when there is a H2O is formed, so this formation is directly related to the combustion reaction. Okay, so we use this reaction to calculate heat of formation, enthalpy of formation. So before that we have the it is a standard condition because the enthalpy is considered here in under the standard condition. So we write here for this overall this we have of CO2 standard heat of formation. This small o right on the edge. Okay, this indicates this is a standard heat of formation. If there is no this symbol, just standard, it is just heat of formation, but this is the standard heat of formation of CO2 which is given minus, this is a minus sign, energy is evolved out, so minus 394.65. okay, standard heat of formation of H2O is given how much? Minus 285.84, there is a kilojoule per mole. Okay, and next one is here CO2 is H2O, there is a O2. So standard heat of formation of O2. And you know O2 is molecular form, O2 is elemental form, and if any molecule is elemental form O2, H2, okay, that time their heat of formation will be 0. So we have this. Okay, so in another side we are going to calculate, we have this value already, it is a heat of combustion, not a standard heat of formation, it is a heat of combustion. Okay, so we write this reaction. So here we write this reaction, we have this reaction plus 5/2 O2 gives twice CO2 plus twice H2O. We use this reaction, we refer this reaction, we have the value of this, it is a combustion value. So this is the reactant, this side is the product. So combustion reaction is equal to heat of formation, sum of heat of formation of product minus sum of heat of formation of reactant. So here, what is the value of heat of combustion? There is a minus 11.67.62 is equal to sum of heat of formation of. So here, this is the product. So there is a coefficient is 2. So 2 into, what is the value? There is a minus 394. So here is a minus 394.65 plus, there is a coefficient is 2 for water into, there is a value is given minus 285.84 minus, we consider here, we are going to calculate heat of formation of CH3, CHO because we have the heat of combustion, but here we are going to calculate, find the enthalpy of formation of acetaldehyde. So we consider for this, it is a X, minus X is considered, plus for O2 there is a 0, there will be the 0. So minus 1167.62 is equal to 2 into, it is the CO2 product plus there is another product, there is a H2O minus, we consider this for X, it is again minus value, so minus X plus O2 has 0. Okay, so what is the answer of here? So minus 1167.62 is equal to, first of all multiply this one, the answer is minus 789.30 plus the second one is, so here the value is minus, so sign is minus, so use here minus, and their answer is minus 571.68. So here is a positive sign, but the value is minus, so we directly use plus minus, there is a minus sign is used here, minus, this is a minus sign, there is a value we are going to calculate, so X, there is 0. So when we consider this is a minus 1167.62 is equal to, this minus minus comes together, there is a positive value, and the answer is their answer is 71, there is a 1360.98 minus x. So this add together, there is a value, so the sign is minus. So this minus 1167.62 minus this is add together, these two add together, so 1360 minus x. We are going to calculate x here. So x is equal to these are minus, so here is a minus sign, okay, and these are subtract from each other, and when they subtract from each other, the answer is minus 193.36 kilojoule per mole. So it is first numerical problem. So this is the reaction, combustion reaction. We have already the heat of combustion of acetaldehyde, but here we are going to calculate, we are going to find heat of formation of CH3CHO. Okay. So when we heat of formation going to calculate, it is the sum of heat of formations of product minus sum of heat of formation of reactant. So this is reactant side, there is a product side. So here product is minus, there is a CO2, there is a 2, this is a coefficient, okay. So 2 into minus 394.65 plus 2 into minus 285.84 minus, there is a second term, we consider x here, and this is the 0 for this one, okay. When on next this two add together, the answer is, so this is the 789 for CO2, 571.86 for H2O, this add together, there is a 13.6260 minus x, and 1167.62 is the heat of combustion. When these subtract from each other, the remaining is heat of formation of x, and x is the here is the CHO. So it is all about the first problem. Okay, the second problem is calculate heat of formation for reaction CO2 plus H2 gives CO plus H2O. The given that there is a heat of formation of CO2, standard heat of formation of CO2, carbon monoxide and H2O are given, are 393.5 for CO2, 111.3 for CO and 241.8 for H2O respectively. So calculate the heat of formation of reaction. The reaction is given to you, CO2 plus H2 all are in gaseous state, converts into CO plus H2O molecule. Okay, so how to calculate heat of formation of reaction? It is the calculated using this formula. Heat of formation of product, standard heat of formation of product minus standard heat of formation of reactant. So in given reaction, there is the reactant, here are the product. Okay, we have the value of CO2, CO and H2O. So CO, the value is minus, so here is equal to, so here how many, all are in single, so there is no coefficient, single coefficient. So CO, the value is minus 111.3 plus minus, for water there is a 241.8 minus, at the reactant side there is a CO2, have the value of CO2, there is minus 393.5 plus, there is a H2, is the molecular form, is the element form, so their value will be 0. Okay. So there is a minus, they come add together, so there is a 8931.123.5, so 353.1, okay, so sign is minus here, and this is 3 minus 393.5. Okay, so here is a minus, so the value is minus minus plus, sorry, it is a plus value. So 353.1 minus, so plus minus minus, so these are subtract from each other. The answer is 40.4 kilojoule, 40.4 kilojoule. So this, sorry, here this plus plus add together, plus here is a minus sign, so minus plus, here is the, there is a subtraction, so answer is 40.4, and the sign is given here for larger value, it is the 394, that's why here is a plus. 40.4 kilojoule per mole is the energy, is the heat of reaction for this reaction. So this is the answer. Okay. So I repeat again, heat of formation is calculated by using this formula. Sum of heat of formation of products minus sum of heat of formation of reactant. Here heat of formation of product side has CO as well as H2O. This is for CO, this one for H2O. When we add together, the answer is minus 353.1 for this one, plus here the sign is the minus, so minus plus will be directly converts into positive sign. So minus plus, there is a subtraction of each other, so 353 and here is a 393. So the answer is 40 point something, 40.4 kilojoule per molecule is the heat of formation of a given reaction. Okay, the third number problem is enthalpy of formation of ethyl alcohol CO2 and H2O are minus 277.0 for ethyl alcohol, minus 393.0 for CO2, minus 285.8 for H2O. Calculate the enthalpy change for the reaction. The reaction is given to you. C2H5 plus thrice O2, there is oxidation, converts into twice CO2 plus thrice H2O. When you are going to solve the problem, you use calculator. तुम्ही calculator use करायचे, values टाकून बघायचे. इकडे तिकडे error असेल तर समजून घ्या. Okay, so just how to solve. बाकी values तुम्ही verify करायचे आहेत. Calculation करताना calculator use करायचे आहे, तुमच्याकडे असेलच तुम्ही करून बघायचे. Already ज्यावेळेस notes दिलेले असतात. So this is reaction which is given to you. ही reaction दिली आहे तुम्हाला. And we have the values. And what is the aim? To calculate enthalpy change of the reaction. Just heat of formation काढायचे. Okay. So heat of formation, how to calculate? You know, there is a sum of heat of formations or standard heat of formations of reactant and products. Depends on reactant and product. So the formula is heat of reaction is calculate. Okay, change in heat of enthalpy or change here is what? Change in enthalpy of reaction. Okay, in standard condition or not. Here is a sum of standard heat of formation of product minus summation of delta H standard heat of formation of reactant. Okay, so product minus reactant. Here what is the product? There is a twice CO2 plus thrice H2 is the product. So 2 is the coefficient, so 2 into their value is, for CO2 the value is second number, this is 393.0. Okay, plus there is a coefficient for H water is 3, so 3 into their value is this one minus 285.8 minus. This is the reactant side. In reactant side, ethyl alcohol is present only because O2 is element or molecule, so their heat of formation is 0. O2 is elemental form in nature, okay, natural, O2, H2, etc. Because they not form on the combination of two different kind of atoms. There is a home atom, single atom, same atom, so it is not formed. So it is naturally available, H2, O2, but other than there is a heteroatoms present in molecule, it is formed by the different combinations. That time there is a heat of formation is exist. Otherwise for O2 and H2 there is no heat of formation. So this side we have the value. What is the value? 277. So here minus 277.0 plus 0. It is a second side. Okay. Once we put all the values there, then what is the answer of this one individual? So 2 into 393. So 2 into 393 minus 787.0 minus 7.80 plus what is the, so here this is the plus, okay, and this is the minus. So here we consider minus for this one, not put here plus, this is the minus because the answer, we just write answer here. So answer is, here is a plus and then we write the minus. So the answer is 3 into minus 285, the answer is minus 857.4. Here minus plus, minus minus, there is a plus 277.0 because there is no value. These are add together, the answer is minus, there is a, I think there is a 1644.4. Okay, so here you correct the values, if may be possible, it may be changed, but you correct using your calculator. कोणाचं calculator वेगळं असेल, माझं वेगळं असेल. Okay, but there is a solve problems, how to solve. When we are going to solve the problems which are in exercise, that time actually our answers are correct or not, we are check on that time. Okay, so minus, sign is here minus, okay, these add together, the answer is 1644.4 plus 270. So minus plus minus, so these are subtract, this is the subtraction, so the larger value has minus sign, so minus is here. Okay, so this is a minus plus minus, so this is a subtraction, so answer is 1367.4 kilojoule per mole. So here is the delta is 0. Heat of formation, enthalpy change म्हणा किंवा त्याला heat of formation of reaction म्हणा, both are same. So this is all about the today's lecture. In next lecture we discuss some points and other numerical problems. Okay, so we stop here.